So, hello everybody. My first time on stage here. Nervous, of course. Thank you. So, my speech is about keeping hundreds of Windows Zabbix agents in sync. So, first, who am I? So, Marco Hofmann, I'm an IT specialist at Anaxco GmbH from Germany. And my two main areas at work are monitoring all of our customers with Zabbix, and second, app and desktop provisioning with Citrix. So some of you might already know me, as I'm one of the moderators of the Zabbix Telegram community and also the moderator of the Zabbix Reddit community. Before we start, I've prepared a short disclaimer. Two of the tools we are going to use are developed and maintained by Bernhard Linz, who is a Zabbix administrator from Germany. His tools, install Zabbix agent.bat and agent auto update .exe, are free to use and open source, so all of you can use his tools. And he hosts a German wiki about Zabbix and IT in general over at snil.net. And second, during this speech, I'm going to make heavy use of Azure DevOps, but it's not mandatory to use this tool to fulfill this concept. It should work with any agent-based CI/CD solution. So let's get started. Why do we need this concept, and what are the challenges we face every day? Let's imagine you're a managed service provider or an enterprise-sized company. Have you ever asked yourself the following questions? How many Zabbix agents can you deploy at once? Do you need to maintain customers without direct access? Have you ever thought of switching to Zabbix Agent 2 in less than a few minutes? How long does it take you to onboard a new customer? And finally, can your Zabbix agent deployments scale limitless? If you need the answer to one of these questions, maybe your Zabbix inventory looks like this. All versions starting maybe from 2.0 up and until 6.0 are mixed up. Nothing is in sync, agents have been deployed and not been maintained since. We don't want that. What we want is a Zabbix inventory that looks like this. All versions in control, everything in sync, and everything is maintained. To achieve something like that, we have 6 challenges. The first, we want to introduce a Git-like revision system to keep track of our changes. Second, we want to be able to target each and every Windows server in our customer's environment. So for example, as a managed service provider, we have maintenance contracts that we have to fulfill, and we must not miss any Windows server from our customer's environment. Then we have our challenges 3, 4, and 5, which are nearly the same. First, we want to keep our agent binary files up to date. We want to keep our Zabbix agent configuration file up to date. As the Zabbix binary version changes, maybe we need to adapt the configuration file. And we want to be able to distribute newly custom developed user parameters. And finally, we want to be able to scale limitless across dozens of customers and thousands of agents. So before we start, let's take a short look at the methods and tools available we use to install Zabbix agent. First, there's the classic method we all know. We download the zipped binary files, extract them, install them from the command line. We need a prepared configuration file, which will then register the Windows service. Then there's the more modern approach to use the Zabbix provided official MSI files. We can use the GUI or the command line, which will then create a configuration file and register the Windows service. For our concept, we still decide to use the classic method because the tools we use already exist since 2013. And the official MSI files were just introduced 6 years later in 2019. If we would use the MSI files instead, the results could be the same, but we won't change an established process that has evolved over 8+ years. So now that we know what we are going to do, let's take a look at a high-level overview. From now on, everything we do will start from the Git repository. In this case, our Azure DevOps Git repository. From there on, we are going to use a tool which is called release pipeline, which will maintain and fill one SMB file share for each of our customers. Starting from the SMB file share, we are going to make use of group policy preferences, which will install the agent onto each target Windows server. With the installation of the agent, we also install the agent auto update exe, which will then periodically check the SMB source for changes, and if there are changes, it will automatically adopt. So, with all tools in place, with the concept in place, I will now explain all of the tools in detail, starting with the 3 tools from Azure DevOps. Git has become the industry standard to keep track of source files. So we are going to host the contents of our SMB master share in the Azure DevOps Git repository. On the picture you can see a folder tree, and most important, the 3 binary files from the classic method, which are there ready for deployment. So these slides are very demo heavy, so we start with our first demo. Let's take a look. From the download page, we already downloaded the latest version of the Zabbix agent, in this case 6.0.8. We extract them and have access to the 3 binary files. We switch over to our Git repository and prepare an upload or a commit. For this, we need a commit message, and we need the payload, which are the 3 binary files. Now, with everything in place, we create an upload. After the upload, we can see that the commit message has changed from 6.0.7 to 6.0.8. But most important, we have a history, which we didn't have before. So we can see the last 4 changes, what was changed, who did it change, and when was it changed. So our first challenge is already solved by just introducing Git into our workflow. The second tool is the on-premises agent. The on-premises agent allows us to deploy our Git repository using an Azure pipeline. For this project, we will install 1 agent per customer that will then host the SMB share with the agent installed. So this share will then host the setup files. So let us take a look at a demo, what it looks like to set up the Azure DevOps agent. In our deployment group, which contains all the agents, we select register, which will then create a 1-line evergreen PowerShell command with a one-time access token. This token is not valid anymore, which will do the complete installation for us. It starts by downloading all the necessary files and will extract and install them. In between, there will be a few questions to answer. Most important, the agents want to be tagged. The tags are later then necessary for the release pipeline to target the right agent. So the download was successful. The agent now registers itself. After the registration, I'm going to enter the tagging for the agents. So tagging was successful. Setup will finish now. And the agent will restart, and the setup is finished. Afterwards, we can check the file system. And in the file system, we can see that the folder AZ agent was created with all binary and configuration files in place. And also, the Windows service was created and is up and running, and it's now ready to accept commands from the DevOps. So the third tool from Azure DevOps is the release pipeline. A release is always based on a commit from our Git master branch. This is then called an artifact, which is copied over into the on-premises agent. And inside the agent, the deployment task will be executed against our cached artifact to create a customer-adjusted result. So this is what it looks like in the Azure DevOps portal. We have 3 tasks, which the artifact will be manipulated with. First is the PowerShell task, then there is a replace tokens task, and finally a copy files to task. I will explain each of these steps now in detail. First is a script which I call new Zabbix agent share.ps1. The script first checks if the target folder already exists, and if not, it will create the folder, for example, when it's a new customer. Then it will make this folder an SMB share with the appropriate permissions. And finally, it will always override the NTFS permissions to make sure every folder is secured, so should we decide to alter these permissions afterwards in the script. And the second task is the replace tokens task. It's a free marketplace function that can replace tokens in any text file. So on the left side, you can see our original file, and on the right side, you can see the already deployed file. So every word that is now surrounded with hash curly brackets will be replaced with the appropriate customer-adjusted variable. And the token translation table for that is maintained in the Azure DevOps portal. And the third task is the copy files to task, which is a standard Azure DevOps function that will simply copy over the content of an already cached artifact. So in this case, we first already created the target path during our first task with PowerShell and created the SMB share with the NTFS permissions accordingly. Then we manipulated the files in task 2 to correspond to the target customer's environment. And now finally, we will copy over this artifact into the SMB share where it will be accessible for every member server. So let's take a look what it looks like to execute a release. So first we start to create a new release. And if you look closely, you can see that the artifact is based on the latest commit. So now we decide to say, okay, this is what we want, we create the release. It will now get queued up in the Azure DevOps portal and will wait for resources to be available and then start executing. We will now check the details to see each of the steps are already explained executing. So now the task starts, and the first thing that always happens is downloading the artifact, which is the latest Git commit, to the on-premises agent. After the download, the 3 tasks I just explained will execute. First, the PowerShell step. And as you see on the right side, there is no Zabbix folder yet, so the script will create the folder and adjust the permissions. Afterwards, the artifact will get manipulated through the replace tokens task and copied over into our just created folder. The files are all in place and the release was a success. Our Zabbix agent share is now available for deployment to each member server in the domain. So now that we have our share, we want to deploy this agent to every Windows server. Therefore, we assume that our customer's environment is based on Microsoft Active Directory, and so all Windows servers are domain joined. And as we have access to Active Directory, we have access to group policy preferences, but more specifically, managed scheduled tasks. And now with our SMB share as a source, we will have this call for the install Zabbix agent.bat, which we have to deploy to every Windows server. Let's take a look what it looks like to set up this task. On the left side, you can see a group policy editor, and on the right side, you can see a member server, which doesn't have the task yet. So we will edit a group policy that will target every Windows server. And inside the group policy, we switch over to the managed scheduled tasks. The task will need a name. I decide for install Zabbix monitoring agent. And it will need a user which will execute the task. I decide to use the system user, but I have to replace it because the system user is not language agnostic. So I replace it with the SID so it works in a multi-language environment. For a trigger, I say to run once every day at midnight, but I also set a random interval so the file server does not get overloaded if I have thousands of agents that will install at the same time. As an action, I just copy over the call that we have seen in the slide before. And under conditions and settings, I just set a few standard settings that are not important for the success of this task. Now I close and save the editor and switch over to the member server, which doesn't have the task. And to speed things up a little bit, I execute GP update, wait a few seconds, and check the task scheduler. to see that the task was created. And I now, to speed things up a little further, execute the task on demand, which is successful, and now Zabbix agent was installed. And with this successful task, I know that later this day at midnight, every Windows server will receive the task, every server will execute the task, and they will have Zabbix agent installed. So every Windows server was targeted and no Windows server was missed for this particular customer. So we already have used the install Zabbix agent.bat, and the agent auto-update exe will now be more important. So I will explain both of the tools from Bernhard Linz now. First, there is the install Zabbix agent.bat, which is a command line script written by him in 2013 that will dynamically create a Windows Zabbix agent configuration file on the target Windows server. It can be discussed that a script is still more flexible together with the classic exe file than the MSI file, because the MSI file has strict parameters I have to use, and in the script I can do what I want, only limited by my scripting skills. And you might ask if a PowerShell script would not be more elegant and contemporary, and I agree, but when we adopted this solution, Windows Server 2003 was still supported, and the scripts was still very well on Windows Server 2022. So more important, the agent auto-update exe. Every time this tool is executed, it accepts two parameters. First, an SMB share as a source, and second, the install Zabbix agent.bat as an action. During each run, it will then calculate the MD5 hashes of each source file in the SMB share. It will then cache these hashes in the registry. And now during each run, it will compare the already cached hashes with the live hashes. And if there is any deviation, for example, a hash changed or is added or is missing, this will count as a change, and this will trigger the second parameter, which is the reinstallation of the agent by calling the install Zabbix agent.bat. So for example, in one of the first slides, we prepared a Git commit with the latest Zabbix agent version. This will, of course, change the hash file in the registry, in the source, but not in the registry. This will count as a change and will trigger an update. Or we develop a new user parameter. We'll add it to our configuration files. This is also a change. This will also trigger a reinstallation. So, slowly coming to an end. I've explained all the tools. Let's take a look what it all looks like working together. So what we have now established is a change-based process. Everything we will do from now on always starts with a change. And a change is always pushed to our Git repository, in this case, our Azure DevOps Git repository. And with the help of our Azure DevOps agents, one installed per customer, we are going to make use of our Azure DevOps release pipeline, which will create, maintain, and fill our customers' SMB share. From there, we make use of group policy preferences, tagging each and every missing Windows server, which will install Zabbix agent, and together with Zabbix agent, always install the agent auto-update exe. If Zabbix agent was already installed, the agent auto-update exe will periodically check the SMB source for changes, and if there are changes, it will adopt to these changes. The circle closes, and starting with our change, we've distributed it among the whole infrastructure. Everything is now well maintained, everything is in sync, and the next change only will happen if we push a change to our Git repository. So coming back to our 6 challenges. The first challenge was we want to be able to keep track of changes, and we achieved that by introducing Git into this concept. The second challenge was to target each and every Windows server, and we achieved that by making use of group policy preferences. The challenges 3, 4, and 5 have been solved by using the agent auto-update exe, which will keep our Zabbix agent binary file up to date, and we keep our Zabbix agent configuration file up to date. And we are also now able to distribute newly developed custom user parameters. And finally, we want to be able to scale limitless. And to be honest, I don't know if it's really limitless, but I haven't been able to hit any limits, and I don't expect to hit any limits. And so far, this is working very well for us. If you like this concept, I've put together a few references, which you can look at later. Most important, the tools from Bernhard Linz, and I've uploaded the script new Zabbix agent share for the DevOps pipeline. Thank you very much. Have a great time at Zabbix Summit.
Thank you for the presentation. That was interesting. And we do have a question.
Okay.
So why exactly like that? Have you ever considered to use some, let's say, software automation like Chocolati or something else?
Yes, we have a software deployment in place that we make heavy use of, but we have customers without direct access and where we don't have the permission to use our deployment software. And we had always the problem that we missed Zabbix servers. And therefore, we switched over to making use of the tools that are available inside the customer's environment without third-party tools, and something that will still work if we don't have access to the environment anymore. So if this is set up once initially, we don't need direct access anymore to be able to still fulfill our monitoring contracts. So this is the reason we switched from software deployment and third-party tools to using the agent-based pipeline and not any third-party tools.
Thank you very much.